Have you ever heard of bilibili before?
Yesterday we were in the Mocha Museum in People's Square, and there we saw bilibili. I also saw some things from bilibili, some cartoons. I was able to use a computer almost 60 years ago because I was doing science. For this reason, I can use my phone as well as a 15-year-old today. The Nobel Prize is a strange prize because unlike any other prize, you don't know you're going to get it. Being a scientist is, I think, a wonderful thing to dream about doing. What scientists do can discover things that can really change the world. Hello friends of Bilibili, I'm Michael Levitt. It's a pleasure to meet you all. Bilibili, cheers.
B 站新会员，嘉宾完成信息卡，成为新会员。
My name is Michael Levitt. I'm a professor of structural and computational biology at Stanford University. My research field is to use computers to study the molecules that are responsible for all life. It's a little bit like we use computers to study the weather or computers to study how cars move. I use computers to study the way molecules move. My hobbies, I travel, food, music, family, and my work is also a hobby because in fact I don't really think I work, although I work all the time. Currently working on, since the 26th of January, I've worked at least 10 hours a day trying to understand the COVID-19 outbreak in the world, to understand the biology of the virus, the way the numbers change, what the data is telling us. I worked out that this has now really been 2,500 hours of work, so really has been very, very hard work.
Okay, thank you. Let us start the official interview part.
请开始你的表演，正式访问，你想知道的都有。
Hello, Professor. We know the reason why you came to Shanghai this time is to participate in the coming Third World Laureates Forum. Could you introduce this forum very briefly to our audience?
The idea was that we needed scientists, world-leading scientists, to get together to discuss problems, but also to be an example to young people. The Nobel Prize is a strange prize because unlike any other prize, you don't know you're going to get it. So if you are going to win a prize for music, you're in the competition, you know that you or 3 other people will win. But for the Nobel Prize every year there are thousands of people who could get it, and it's all secret. So until the phone call comes, you don't know, and suddenly your life has changed. And initially you think, why has this happened? What should I do? Just carry on like the day before. And then you realize that when I was young, what was very important to me were the rock stars of science, the Nobel laureates. When I was 16, I heard a television program by a Nobel laureate and it got me into science. So I realized that one of the roles of a Nobel laureate is to popularize science. And popularizing science means communicating sciences to the youngest people in the world, children, people growing up, because science is something that anybody can love. It is not something that is either for women or for men or for certain nations. Also, the results of science benefit everybody. So I think science is a good thing, but it's important to act as a representative of science.
Okay, thank you. You won the Nobel Prize in Chemistry as a biophysicist. Besides, the 2020 Nobel Prize in Chemistry was awarded to genetic scissors, which seems more like biology than chemistry.
基因剪刀是修剪基因的工具，人类为什么要主动修剪基因？这就是基因剪刀存在的意义。DNA 是生命的蓝图，细胞蛋白质的生产、维持生命的正常运作都依靠 DNA 的指挥。但是当某些 DNA 的片段发生改变后，细胞的运作可能会失控，很有可能不能生产你所需要的蛋白质，这就导致身体机能的失控，会出现诸多遗传疾病。一般的疾病吃药可以根治，但是遗传类疾病药物只能起到维持或基本控制病情的效果，患者基本上要终身服药。想要根治，只能修改错误的蓝图，所以找到一把准确的能够有效切开 DNA 的剪刀是解决这一问题的关键。
Do you think we should change our current understanding of chemistry?
I think the different subjects are really defined, I think, at school. Because if you think about it like mathematics can apply to everything. Computer science applies to everything. Chemistry is the study of molecules, and everything is molecules. Some of those molecules may be important for medicine. Other molecules may be important for biology. Other molecules may be important for materials. So I think the boundaries actually are very artificial. They come both from schools and from subjects. I think everything connects, it's all science.
Has this kind of interdisciplinary research become a new trend now?
I think research has always been interdisciplinary. I think that, as I said, I think the boundaries between subjects are very old, and the reason I think they exist is because people would like chemistry to be taught by somebody who learned chemistry at the same university. Even if they teach physics instead of chemistry, these boundaries make no sense to me, and I think everything is interdisciplinary. I think the whole world is one thing in exactly the same way that all people are people, and all science is science.
We know that you're highly concerned about the COVID-19 pandemic. Your Stanford team and international volunteer team are working tirelessly on COVID-19 data analysis. It is said that your mathematical models are different from others. Could you explain more about this?
Biology is very complicated. And if you think you can predict how a virus will develop without looking at the virus, you're making a big mistake. No matter how good your mathematical model is, you need to look at the virus. And one of the interesting things about COVID is that it doesn't grow exponentially. And we would expect a virus to grow exponentially because if I affect 2 people and each of them affects 2 people and so on, that's exponential growth. But COVID doesn't work like that even from the beginning. And I think the reason COVID doesn't work like that is because many people are infected but have no symptoms. So when you count 2 people, you're actually counting more people and all the numbers get mixed up. I think my approach has been very much to look at the data and then make mathematical models. The mathematical models are maybe at the level of first-year university or maybe a smart high school. So it's not nuclear physics, and that is actually very reassuring. A virus is a very simple object. Human beings are very complicated, but the virus itself can't just do whatever it likes. It needs to grow in certain ways, and this has been important.
What do you think is the most important thing in fighting the COVID-19?
I think the reason is probably due to existing immunity from other viruses that have spread here a lot, or maybe something in the food. We don't really know why. Maybe even blood groups. On the other hand, one has to also remember that viruses are a little bit like wood. If you come to this room which is covered with wood with a match, you probably won't cause a fire. But if I come to this room with a match and a big can full of gasoline and I put gasoline over all the chairs and light the match, I will cause a fire. And that fire might be very dangerous for all of the area. So with viruses, if it gets very hot, if many people get infected, then you can infect more people. But if you control it by not letting the fire burn at the early stages, it's relatively easy to control in East Asia, not so much in other places.
Professor, are you still working on the virus and any fresh results?
I am currently working on the virus. We have a paper we're trying to get finalized for publication, but we're also working on lots of other aspects. For me, the virus is the easy part. The hard part are people. And unfortunately, COVID-19 is not just the virus. It's the virus interacting with all of society. And I think society needs to be very smart to deal with the virus, and this has not always happened.
Professor, have you ever worked with Chinese colleagues?
Yes, I work with Chinese colleagues all the time. I have many Chinese students at Stanford. I basically really see people as human beings. So I work with human being colleagues all the time, and it doesn't really matter too much where they are from. In fact, I like diversity. I think that one of the most important things in life is to have a diversity of people, a diversity of gender, men and women, and a diversity of opinions. You want people who don't agree with each other. If everyone agrees with everybody else, there'll be no solution. I think the greatest message for young people is that you have to embrace people who are different from you, because people who are different from you, under some circumstance, may save your life.
Thank you. Have you ever heard of Bilibili before?
Yesterday we were in the Mocha Museum in People's Square, and there we saw Bilibili. It's an exhibition about Snoopy. It's actually very profound. So although it's popular culture, it really was very interesting to see the way this American cartoon had been connected to China in a very interesting way. And I think, I also saw some things from Bilibili, some cartoons, and I think it's very important to, again, diversity. I feel like that's a wonderful example of diversity, where you have a museum of contemporary art, a very serious museum, a serious curator, a cartoon character, a funny dog, all mixed up together with Chinese art. And this diversity is what makes life so wonderful and so rich.
Thank you. Many of our audience on Bilibili dream to be a scientist in the future. So what's it like to be a scientist?
Being a scientist is, I think, a wonderful thing to dream about doing. I probably wanted to become a scientist when I was 15 or 16, but I had an uncle who was a scientist and an aunt who were a scientist, so I knew what scientists were. Science is wonderful because you're essentially trying to solve puzzles all the time, and you are paid to solve puzzles. You are given the tools you need to solve puzzles. I was able to use a computer almost 60 years ago because I was doing science, and nobody in those days had a computer. For this reason, I can use my phone as well as a 15-year-old today. So that was very important. I think that there's nothing better for science, because what scientists do can discover things that can really change the world. And sometimes a very small discovery can become a very large discovery. I would also say, though, that if you do science, you shouldn't do it because you want to get a Nobel Prize. You have to do it because you like doing it.
Could you give some advice to these young people?
I think my advice that I actually generally give in my talk is, firstly, be passionate. Do something you really like doing. If you want to become a musician, even a pop musician, and your family wants you to become a doctor, you probably should listen to what you want to do, not what your family does. Now, if you're clever, you might find a way to become a doctor and a pop musician. Then you would invent a new interdisciplinary area which might be very, very important. We don't know. The other thing is, be very persistent. Don't give up. Because in life, people will tell you not to do it. They will say you shouldn't be doing it. It doesn't make sense. It's wrong. So you have to believe in yourself. Every young person should believe that they are capable of doing the best things in the world, because they are. We don't know that. Everyone here should be feeling that they can do it. It's important to respect the elderly, but it's also important to respect the young people. We should always respect each other, because with respect, we can hear the other person's voice. We want diversity, so respect is important. I think beyond that, I think it actually helps in life to be a nice person. Sometimes people in life who are not nice people succeed, but I think deep inside they are hurting many people around them, and in the end people will be against them. And it doesn't matter whether it's a scientific colleague. In order to be recognized in science, you have to build on the work of other people. You don't have to do everything yourself. So I think appreciating other people is also very, very important for a career in science. You must tell me when to do it, so this is the last one. It's always the best at the end. This camera or that camera?
This one.
That one, yeah, that's what I do, 15 degrees, okay.